So we're going to continue with our parallelograms, and rhombi and squares are another type of parallelogram. So a rhombus is a parallelogram with all four sides congruent. So all of the things that apply to a parallelogram also apply to a rhombus, but we are adding that all four sides are congruent. And that is the unique difference. Now, because of that, if a parallelogram is a rhombus, then the diagonals are perpendicular. So if I were to draw in my diagonals, they intersect at a 90-degree angle. They are perpendicular to each other. But the same applies, though, as a parallelogram, is that they do bisect each other. So we do create those that midpoint effect. And then if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. That is something new now. So each pair bisects the opposite angles. So this angle is going to be congruent to this angle. This angle is going to be congruent to this angle. This angle is going to be congruent to this angle, which is going to be congruent to that angle and that angle. And then these have these four angles. This, and this are congruent. This, and this are congruent. So there you go. Those are some of the new characteristics or the new theorems, things that we can use as definitions moving forward. Let's see here. Now, a square is a parallelogram with all four sides and all four angles congruent. So a square is a rhombus, but it is also a rectangle in the sense that I have my opposite angles are 90 degrees. All four angles are congruent. So in order for all four angles to be congruent, they would have to be, all four angles would have to be 90 degrees. Otherwise, all the properties of a parallelogram and rhombus apply, but when my opposite angles are, when that rhombus has 90-degree corners, it turns into a square. We have a special name for it. Okay, so looking at that, here we're talking about the definition, using that definition. So if this is a rhombus that we're looking at, right, in rhombus, KLMN, LM is equal to 2x minus 9. So looking at my image, LM, this is 2x minus 9, and KN is x plus 15. Well, part of that rhombus is we know that all sides are congruent. So I know I can make LM congruent to or equal to KN. So that's what they've done. And we have making those two things equal. Doing my inverse operations, going to go ahead and subtract x from both sides to get all my variables on one side. Then I'm going to subtract 9 from both, or add 9 to both sides to get my numbers together, and it'll find out that x is equal to 24. So that is the value of x that, of course, makes this a rhombus, because then my sides are congruent. So I know all of these sides, oops, not 24, right? X is 24, so this would be 24 plus 15. So I know the complete length over here should be 39. So this is 39. This one is 39. That's just things I know. Okay, so looking at the check, let's see, what do we know if this quadrilateral here, WXYZ, is a rhombus? So I know that this is 90 degrees. I know that this and this and this and this are all the same length. I know that this should be congruent to that because the diagonals bisect each other. I know that this one should be congruent to that. I know that this angle and this angle and this angle and this angle are all congruent. I know that this angle is congruent to this angle, which is congruent to this angle, which is congruent to that angle. All right, so that's all the stuff I know based on the properties of a rhombus. Let's see here. AZ is 14. This length is 14, so I know this length is 14. ZY is 22. This is 22. This is 22. This is 22. This is 22. And then angle WYZ, WYZ, so this angle right here is 35 degrees. Then I know this is 35 degrees. This is 35 degrees. This is 35 degrees. If this is 90, right, this is 35. Oop. That's 35. If this is 35, then that makes this 90, 35. This should be 90, so 90 minus 35. This should be 55 degrees. 55 degrees, and I know that this is 55 degrees. This one is 55 degrees, and this one is 55 degrees. Okay, let's see, what have I gotten any of my answers here? Let's see here, the measure of XYZ. XYZ is this entire corner. 35 plus 35 is 70. Then they asked me for WXZ, WXZ. This angle right here we said is 55. And then XZ is this entire length, right? XZ, so it would be 14 plus 14 is 28. So there you go. Using the properties of rhombus, those special characteristics to be able to fill in those answers. So, okay. Using the diagonals of a rhombus. Oh, okay, let's see what happens. The diagonals of a rhombus, KL, MN, okay, intersect at P, great. And then LMN is, this entire angle right here is 75. Okay, so that is 75 degrees, which would tell me then that this should be 37.5 degrees, 37.5 degrees, because that would be half of 75. Okay, so let's see, and then if that's the case, because it's a parallelogram, I know that this angle right here plus this angle, because, you know, just thinking of the whole thing, this whole thing should be 105 degrees, this whole thing right here. So that makes this angle should be 52.5 degrees, 52.5 degrees. And let's see, with that, what are they asking us? Find KNP. KNP. So they want to find this angle right here. Now we know this angle is congruent to these two angles because all four of these angles are the same. So I'm thinking this should be 52.5 also. So there you go. That's how we can come up with that information. Now they of course did some math here that we didn't necessarily do, but if I know that this is 90 degrees, again, this plus this plus this all equal 180 degrees. They did some substitution and came up with the information also. Just depends on how you process and how your mind's thinking. The definition of a square. All right, now with a square, we find out that we know that, just thinking about this, it tells me that FJ is 19, okay? And we want to find FH, this entire length right here. Well, I know that a square is like a rectangle where my diagonals bisect each other, or a parallelogram, but my diagonals are congruent. Okay, so I know that this is 19, this is 19, this is 19. So with that, I can simply say, well, if FJ is 19, then FH all the way across would be 19 plus 19, which is 38. Okay. And if I had this, I have 90 degrees. So if I needed, I could calculate that value right there based using the Pythagorean theorem. But we will get to that, okay? But just thinking, if I have a right triangle, there's always a way to find the missing length. All right, so this rhombus, let's see here, PQRS. PQ is 4x plus 3. 4x plus 3, QR is 41. Remember, we know, I don't know how much farther I need to get to, but I know that these sides are all congruent. And then PQT is PQT. So PQT, this angle right here is 2x plus 4y. And I would say that we know that those measurement angles are, let's see, if this is 90, this is 90, so that makes each one of these individuals 45 degrees if the total corner is 90. So we do have the information we probably need. I know that this corner is equal to 45 degrees, but I cannot solve that equation yet because I have 2x plus 4y. I have two variables in there, and that's chaos. We can't solve for two variables at one time, but I do know that those two things equal 45 degrees. So let's see here. What must the value of y be for the rhombus to be a square? Okay, so for this to be 45 degrees, it would be a square. Now, I do know this and this are congruent, so I can make those two things equal to each other. I got 4x plus 3 equals 41. Subtract 3 from each side. I have 4x is equal to 38. Divide both sides by 4. And x is equal to, I think, 9.5. Okay. So now if I know that x is equal to 9.5, I know this should be 2 times 9.5 plus 4y, equals 45. So I have 19 plus 4y equals 45. Subtract 19 from both sides. 4y is equal to 26. Seems okay so far. Divide both sides by 4, and y is going to be equal to 6.5, I think. Okay, so 6.5, and it says, what must the value of y be for the rhombus to be a square? In order for it to be a square, y needed to be 6.5. There you go. And then here, testing for rhombi. Again, this is sort of going forward and back in my statements. You know, we know that a rhombus has sides that are all the same. So, and we also know that they intersect at a perpendicular. If the diagonals of a parallelogram are perpendicular, then we know we have a rhombus. Okay. Definition of a rhombus tells us that they intersect at a 90-degree angle. So if we have that, then we know we have a rhombus. If one of the diagonals of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Again, my diagonals bisect opposite angles. So if I have a parallelogram and the diagonals bisect, then we know it's a rhombus. And then if two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Because that would sort of make that square, right? If two consecutive sides, two consecutive sides, not angles, two consecutive sides of a parallel are congruent, then we know that it's a rhombus because the opposite sides of a parallelogram are congruent. So two consecutive means they're all the same. Okay. So let's see if I have a parallelogram, I know that these opposite sides are congruent. And they're just saying that, hey, if we have a parallelogram and these two sides are congruent, then we know that the opposite sides are congruent to those. So that's how we end up with a rhombus, because then it turns out that all four sides are the same. So here, those conditions, we want to prove that this is a rhombus over here. This is a rhombus. It's a parallelogram, and we know that these two triangles are congruent. So let's see, TSW. TSW is congruent to TSU. Okay, so these are congruent, and it's a parallelogram, so I know that this is congruent to this. They told me that those two triangles were congruent, so if they're congruent, then I know that, okay? And then if it's a parallelogram, then I know that the opposite sides are going to be congruent. So now all of a sudden I have all four sides are the same length, so therefore I would have a rhombus, okay? So just trying to identify the information they give us and what helps us and what doesn't help us. Let's see here. Ananya, okay, is designing a sweater using an argyle pattern. All four sides of the quadrilateral A, B, C, D are 2 inches long, okay? So 2, 2, 2, 2. How can Ananya be sure that the argyle pattern is a square? Well, in order to be a square, I've met the rhombus requirement, but remember a square, we needed to have 90 degrees. That's what we needed to have. So if we have a rhombus that has corners that diagonals or opposite corners that are 90 degrees, then we would end up with a square because that was one of the given requirements. And then that's what they're telling us here, but we could also say both pairs of opposite sides are congruent. Yes, it's a parallelogram. Because consecutive sides are congruent, it's a rhombus. And then if the diagonals of the parallelogram are congruent, then the parallelogram is a rectangle. Okay, so if Ananya measures the length of each diagonal and finds that they are equal, then we have ABC as a square. So that's another way, just doing length and not worrying about angles. I was just thinking in angle form. But yeah, so if I were to measure the length of these two diagonals and they were the same, then I would find that we have a rectangle. That's the requirement for a rectangle, which a square is also a rectangle. So there you have it. And then classifying a parallelogram using coordinate geometry. Goodness. Determine whether ABCD with those vertices is a rhombus, rectangle, square, or none. List all that apply and explain. Okay, so if we do, what have they done here? They have said, let's plot and connect the vertices of the coordinate plane. So I've gone ahead and given that to you guys. To be a rectangle, in order to be a rectangle, ABC has to be perpendicular to AD. That would make it a rectangle. So if you calculate the slopes, remember the slope of a perpendicular slopes, it multiplied to the product of -1. And here when they did the slope of AB, they got 4. The slope of AD was 1/4, which when we multiply that, that just becomes 4 times 1/4, which is 1. The slope is not -1, so therefore it is not perpendicular. If it's not perpendicular, it cannot be a rectangle or a square. But ABC can be a rhombus. The diagonals must be perpendicular. I can calculate the slope of the diagonals, right? So I calculate from AC, and I find out the slope equals 1. I calculate the slope of BD, and the slope is equal to -1, and -1 times 1 is -1, so therefore they do intersect at a perpendicular, and that would help us determine that it's a rhombus. Now, in order to be a rhombus, did they tell us that? Okay, they said determine whether it is a rhombus, a rectangle, a square, or none. All right, so this was the first step right here that eliminated the rectangle and the square because they are both required to have corners of 90 degrees, vertices of 90 degrees. A rhombus, one other thing, we needed to make sure that the rhombus it has all the same length sides. So we want, I mean, I guess we do want to make sure in this sense that we couldn't just, I want to make sure that this length is the same as this length, which is the same as this length, which is the same as this length. So that's another thing that, you know, is going to be important for me to be able to determine if something's a rhombus or not. So there you go. And with that, we are going to go ahead and now explore rhombi and squares.